Hello, boys and girls. In lesson 3.5, we will be looking at similar figures. We will be able to find missing sides of similar figures and determine their similarity by solving proportions. The following triangles are similar figures. How do these figures relate to one another? Use your response to help you create a definition for similar figures. Pause the video to think about it, and then replay it to see if you are correct. Similar figures have corresponding angles of equal measure, and the ratios of each pair of corresponding sides are equivalent. In other words, they are equivalent ratios. So if you notice, the angles are exactly the same size. We have 40-degree angles, we have 50-degree angles, and of course we have 90-degree angles. If we look at the sides, 3/12 reduces to 1/4, just as 12/48 reduces to 1/4. Therefore, when going from the larger triangle to the smaller triangle, a scale factor of 1/4 was applied, making them similar triangles. How would you name each of the sides in the triangle below? This side right here would be called line AB. The blue side would be called line BC, and the green side will be called line AC. Let's take a look at an example. Use the side lengths of triangle DEF and the fact that the triangles are similar to find the lengths of sides AC and AB. So knowing that those triangles are similar, we also know that they are, or that they have, equivalent ratios, or in other words, their sides would be proportional. So let's take a look at each side one at a time. I know that EF corresponds to BC. I also know that DF corresponds to AC. Knowing that they are equivalent triangles because they are similar to each other, I can set them equal to each other because their sides would be proportional. So let's fill in the blanks with the side lengths. So the side length for EF, which is found right here, is 4. The side length for BC is 12. So I will put that in the denominator. The side length for DF is 5. So I will put it in the numerator. And the side length for AC, we don't know, so we can use a variable. Now notice, the numerators are corresponding sides to each, or come from the same triangle. They are from the smaller triangle. So EF and DF are both from the smaller triangle. BC and AC come from the larger triangle. Okay, so let's cross multiply to solve the proportion, and we are left with 4x is equal to 60. When we divide by 4 on both sides, we are left with x equals 15. So now we know that the length of AC is 15. Let's use the same technique to find the length of AB. So again, we have EF over BC is equal to, well, if we want to find AB, it corresponds this time to DE. So DE over AB. So let's fill in the blanks with our values. EF is equal to 4. BC is equal to 12. DE is equal to 3. And AB, well, we don't know what that is. We will use Y for that example. Again, we cross multiply. 4 times Y is 4Y. 3 times 12 is 36. Divide by 4 on both sides, and we learn that Y is equal to 9. Therefore, side AB has a value of 9. Now, thinking back to the definition of similar triangles or similar figures, it said that the side lengths are proportional or have equivalent ratios to each other. If you remember, it also said that their angles are equal to each other. So let us answer the second question posed in this problem. Can you also find the measure of angle D? Here is angle D. Well, if the angles are equal to each other, then we know that angle BCA is equal to 30 degrees. The corresponding angle is ESD, also making it 30 degrees. So now we have 2 out of the 3 triangles in this particular shape. We have angle A, which is 90. We have angle F, which is 30. So far we have 120 degrees in our triangle. I know that the 3 angles of a triangle should equal 180 degrees. So to find that missing angle D, I would subtract 180 minus 120 to give me 60 degrees. Therefore, angle D is equal to 60 degrees. Let's take a look at another example. Using what you know about scale factor, find the missing side lengths of the following similar triangles. So I already know that the triangles are similar, therefore the same scale factor was used to go from triangle DEF to triangle ABC. So if we look at the 2 corresponding sides 4 and 8, what scale factor was used to go from 4 to 8? If you said 2, then you are correct. So if a scale factor of 2 was used to go from triangle DEF to triangle ABC, let's apply that scale factor to each of the other sides. So when we apply a scale factor of 2 to side DF, 2 times 6 equals 12. Therefore, its corresponding side, AC, would have a length measure of 12. In the same way, if we use the scale factor of 2 to apply it to the length of DE, 5 times 2 is 10. Therefore, the measure of side length AB would be 10. In our last problem, a man stands at 6 feet tall and casts a 12-foot shadow. How long would the shadow of a 5-foot tree be? Now, when we think about shadows, the sun casts them in the same angle. Therefore, the triangle that is created by the height, the length of the shadow, and the angle of the triangle would have to be similar. So these two triangles that are created would be similar to each other. Therefore, we can use a proportion in order to solve this problem. So we are comparing the height to the length of the shadow. So we know that the height of the man is 6, the length of his shadow is 12. Similarly, we have a height of a tree, which is 5, and comparing it to the length of its shadow, which we don't know, and therefore we'll use the letter x, or the variable x. Let's cross multiply to get 6x is equal to 60. Divide by 6 on both sides, and x equals 10. Therefore, the length of the shadow would be 10 feet.